Hi, everybody. My name's Angie Byron. I am the head of community here at Temporal, and I am very pleased today to be joined by Maxim Fateev. Maxime, why don't you tell folks a little bit about yourselves? I think most people know you, but in case they don't, how would you introduce yourself at a party with a bunch of nerds at it?
Good question. I don't think I give my life story to them, but I just say that I'm an engineer
Right on.
working on backend systems. That is kind of do. But yeah, if just kind of in general, some of my life story is that I was born in Soviet Union a long time ago, and then studied in a school with like physics and mathematics, advanced physics and mathematics. And then I entered Moscow State University and did physics master degree there. And I was involved in computers and I wrote some code, but I certainly wasn't professional in any case. But then I moved to Brazil and I received my computer science master degree from UFRJ, the State University of Rio de Janeiro. So there I learned about what software engineering is. And
That's a very international. So you grew up in Russia. You graduated from university in Brazil. And Georgia in the US was somehow in there as well. Is that right?
no.
Oh, okay, sorry. I
I have
added
education in Russia, in Russia, in Moscow, in physics, and computer science is only from Brazil. And then I moved to the US in '98. So
nice.
yeah.
That's awesome. You know, normal people, and by that I mean boring people, they don't get into technology. Like they use technology. If their phone breaks, they'll take it to the Apple store, that kind of thing. But you are someone who not only got into technology, got way into technology, and you really like, really just it spoke to you. You decided to get a degree in it, you decided to build a company around it, all these kinds of things. I'm just curious, like, what was your first computer programming language? Like, what was the first problem that kind of spoke to you when you were kind of learning this stuff that made you decide to go deeper? And I'm also going to ask that question to the audience as well. Um,
Actually, since I was a kid, I was into the physics mostly.
okay.
So I had books around physics and all sort of experiments and stuff. And I think my physics teacher in seventh grade got tired of me just like asking questions and trying to do all sort of things. But I think when I was like eighth grade, or seventh grade, I found a magazine which actually explained how to program a calculator. And I didn't have a calculator, but it explained that. So I was writing program. My first program was writing it on the paper, and it was
Wow.
pretty amazing thing because that calculator actually was stack based. So if you needed to write 4 plus 4, you had to write 4 push 4 then plus.
Like
Right?
right out with pencil.
No, yeah, but no, commands would be like that, right? But
Yeah.
it's was programmable calculator, so it was kind of cool. But then my school had access to research facilities, and they had actually a clone of IBM 360 there. Like Soviets just stole it. The technology made their own clone, but the actual operating system was IBM 360. So my first kind of real programming was on mainframe.
Wow.
So
Way to start with something easy and basic. That's a good idea. Yeah. I started on a VIC-20. I'm like of that age. And I used to copy programs out of 321 Contact magazine. And then like it'd be like 4,000 lines of basic to like make a box go boop. But then I would start changing things about it to see if I could make it do something different than that. And so that's kind of what got me into it in the first place. That and lots of video games. I play too many video games. So all right, and then one more kind of intro question again to get folks to get to know you a little bit. You've had a very long career, working at a lot of roles at a lot of places that people have actually heard of and probably use every day. Do you want to just give us like an overview of like, where you worked, kind of what kinds of problems you were solving there, and like kind of what the most maybe one interesting spooky story, from your career kind of going through?
yeah. So when I actually moved to the US, I started to work for big AT&T. I think that original like AT&T, and was an interactive voice response application. So imagine like FedEx and type of like back then in the 90s, it was pretty advanced technology.
Mhm.
Actually written, it was pretty large platform written in Bell Labs initially, so it was pretty amazing for the time. And then I kind of worked for a startup which went under in 2001. But
A lot of startups went under in 2001.
But actually, it was an interesting problem. We were integrating different telcos, so we had to practically write universal translators from different formats. So I wrote like EDI engine. I wrote practically code which would translate any data structure to any data structure. Is a kind of homegrown functional language which could convert to spreadsheets for analysts to look at them and kind of be able to validate conditions and stuff. So it was pretty cool,
Wow, yeah.
like homegrown stuff. And then yeah, and when startup went under, I ended up at Amazon in 2002. And uh, initially, I worked for the ordering team, so practically order history, and also involved checkout pipeline. So a lot of kind of real application development back then. And initially, Amazon was a practically monolith. So I had to deal with a lot of very, very interesting legacy code. Because Amazon at that point practically had mantra get big fast. I don't know if anyone remembers that, but back then it was all about get big fast because they wanted to kind of capture the market, which meant that original Amazon was had very high quality kernel. They but then they get big fast meant okay, let's write code as fast as we can, and you had files of 15,000 lines of like a few thousand lines of single function with multiple runtime conditions, and it was crazy. An interesting thing that at some point it got so large that it took 45 minutes just to link that binary. So any non-trivial change required practically relinking, which meant 45 minutes. And I think total compilation on the high-end machine was 18 hours. So it was, you would never compile it on your machine. It was kind of built, distributed. I don't think it
Wow.
was distributed, but it was like built somewhere else. So, and
So you were basically that
break and
XKCD
master,
comic of like standing on the chairs and fencing because this code was compiling for 18 hours. So what else are you gonna do? That's crazy. Wow.
people, so the worst thing was break and master branch by merge because again, 18 hours and the whole company would stop. And people wrote stories like, okay, how I broke the build in the wiki, so you could see them. So it was something you didn't want to do.
Yeah, okay.
And yeah, and back at Amazon was pretty crazy place. So some couple funny debugging stories was that you know that Amazon has this like yellow line says you bought this thing like 2 years ago already.
Mhm.
And once I got a ticket saying that one somebody reported that they couldn't see the website at all. Likely this like every page would time out. And I started to troubleshoot that and I couldn't reproduce the problem. So at some point, Amazon had this ability back then that you could actually spoof the account and kind of load that account. And like under temporary credentials, like so had some
Right,
security.
like a masquerade system.
Yeah. The interesting part was that then it started to time out. And after troubleshooting, I found that it was loading the whole order history, every line item to calculate that line. And I think
Oh.
they did it twice. But that it wasn't a problem. Problem was that it used an n cube algorithm on number of open line items. So practically after, and that specific person had hundreds of open line items in their orders. And it like this n cube algorithm practically was taking 45 seconds to just to render that line. And the whole website had 30-second timeout. So practically every page was just
Oh, wow.
yeah, so I
Okay.
just changed it to practically use hash map to practically instead of iterating multiple times over the data set and just started to render under 1 second, I think, the whole thing. So yeah, that was an interesting kind of exercise.
Yeah. Oh my goodness. Okay. Well, way to start us off with a terrifying story of trying to debug a website timeout that you can't reproduce and is based on iterating over hundreds of lines of code that eventually hits the website timeout. Wow. So you're alluding to the fact that you have experience with some of the real world situations that cause people to use temporal and seek out a solution like temporal. So tell me about kind of the before time. So at one point in your life, temporal wasn't quite an idea in your head yet, right? Like you were debugging some of these problems. What kind of thing did you see when it kind of very first planted the seed in your brain? Hey, I bet you there's a better way to do this. Do you remember at all, like of a moment or
So
like
it wasn't a moment. It was actually a pretty long path. First thing is that I moved from ordering team to the infrastructure team at Amazon, and I practically became the tech lead for the pops up infrastructure. And initially, we practically just built our own kind of queues on top of Oracle, and then we built our own kind of storage engine. I kind of helped design that and implement the first version of a kind of distributed storage, which is still used by SQS, I think. And as somebody who practically owned PubSub ecosystem, Amazon, I talked to every team who used PubSub, and all backend of Amazon ran on that. And it became pretty clear that you want orchestration, just PubSub systems, just not right way, like event-driven system, not right way to integrate large backend systems. And our team was talking about that for a long time, and we just couldn't like we realized we need something like workflow, and all we knew about that. And then Amazon, by the time we kind of started to think about it, Amazon Web Services were created. So
okay.
and we are like, okay, we need to build an Amazon Web Service, and we tried to kind of design that, and were multiple iterations. And the third iteration ended up being Amazon Simple Workflow, which is still AWS SWF, still out there. But the first version of that didn't have any SDK. It practically exposed workflow history directly, and you had to, as a programmer, deal with that, practically write event loop manually. Then I wrote a framework which was more like step function, so like practically implement like pretty standard approach of doing abstract syntax tree through kind of objects. You instantiate, oh, this is a sequence, this is the activity, this is if condition, so everything would be just an object with all of that, and it kind of worked. I think it was called Decider Framework back then, and this Decider Framework went to production. Quite a few teams used that. But I just hated how verbose it was and how kind of, I don't know, I just felt something wrong about that.
Mhm.
Um, at the
Do you
same
remember like what was it like what gave it like the bad smell or like what kind of got your spidey senses going?
I think verbosity, because reality is like if you want to run like 3 lines of code, you could create multiple objects, and you need to wire them together, and then like troubleshooting that was harder. So, and the other part was that I, doing the PubSub system, I practically at some point wrote it fully asynchronously in Java. And I practically invented my own way to do asynchronous programming in Java, especially kind of not my way, but it was a bunch of like futures and everything. But what happened is that at some point I've got a bug, and it took me 2 days to find a bug. And then what happened is that some exception was swallowed because it's a callback. Some callback just didn't dereference promise at the right point, and that exception went nowhere. And I kind of had to invent my own way to do error handling in asynchronous systems, and when practically you couldn't ignore exceptions and do try catch around asynchronous code, and even finally guarantee that things were executed. So I had a lot of experience with asynchronous code. And then when we started to do this framework, I'm like, okay, can we write asynchronous code to represent business logic? And I had an intern who prototyped that. So he prototyped this, and we were just taking the whole asynchronous graph and serializing every time as a prototype, practically using reflection after every step. And it worked, but certainly wasn't efficient. But when I was troubleshooting this decider framework, I kind of stumbled that it had a very serious bug, which kind of right now all of us would determine is non-determinism, because kind of I didn't even think about it, but I realized that it would take different path in different situations and was causing the problems. And then I realized that you can use replay to reconstruct state, and kind of these two things converged into this what is AWS Flow framework, which implements kind of this durable execution as asynchronous Java code. That is kind of the idea. So it was kind of multiple things with time, and then it converged. And then synchronous, doing how to do workflow synchronously came at Uber, because we had to do Go, and nobody does asynchronous Go just because Go just not language which likes async. So we wanted to do asynchronous workflows, and then I figured out how to do that there.
Wow. Okay, well, that's quite the journey. I'm doing a link dump in the Slack channel for folks who care about clicking on links about stuff. But it sounds like you were leading a team at Amazon or AWS right as AWS Web Services or Amazon Web Services were like being rolled out, which kind of changed the whole paradigm of how programming was done. So you had to come up to speed on that. Then also kind of trying to do these things that really hadn't been done before, like kind of paving new ground with asynchronous Java coding, paving new ground for asynchronous Go coding and all this kind of stuff. But through that process, it sounds like you became very aware of some of both the pain points that people run into when they do these distributed systems, as well as some of the kind of gaps in the solutions at the time. So yeah, that's awesome. Wow. Okay. So Cadence is the thing that Temporal was before it was Temporal. Can you talk to me about that a bit? So you were at Uber at this time, correct? And you didn't have like blessing from on high to solve whatever problem. It was kind of like you saw a problem, you went to solve it, or like how did that all work? Like what was the origin of that, and how did you get it to proliferate across the organization?
So interesting. I joined Uber actually to write a pub/sub system because again, I was
Aha.
writing pub/sub systems all my life. And back then, the Kafka was pretty ancient back then, like very nascent technology, and Uber had issues with reliability and availability. And so practically they hired us to write replacement for Kafka.
Mhm.
And as me having experience with, like doing pub/sub system for Amazon, I was kind of, and they let us to do it as an open source. So I'm okay if I can write this as open source, and I think I can do better job then. And we actually implemented. It's called Jeremy. You can probably Google my last name and Jeremy. You will find blog post about that. And we bought 60 teams at Uber using that at some point. But then practically what happened, Kafka had a new release and they improved a lot. And just Uber at the kind of management level decided not to fund our initiative. So we cut funding. But while developing that, we practically, because we did it to support very large clusters, we need to do background jobs. Practically just also do background operations to maintain those clusters. And when we started to think about it, Samar, who's co-founder of Temporal and CEO now, he said, okay, why we just don't do something we did at Simple Workflow, and we work together at Simple Workflow with Summer, and we kind of started to work on that, and the prototype that was so practically without any top down. It just okay, let's do background jobs, and then at this time, kind of project itself started to die, and we kind of branched off and just made it its own thing. And Uber was a great place because they let us do it. Like they gave us practically another developer and or even two, and we took a half a year to put the first version in production, and they
Mhm.
let us do it. And
Wow.
after that, we found a few internal customers, and we started kind of get practically kind of the same thing you do with open source. You go around, you get one customer, you get a second customer, and you kind of grind through the adoption curve, especially initial one. Took us 2 or 3 use cases first year, I think, then like 10, 15 maybe next year, and then we got over 100 third year. And first 2 years, and it was built as open source. Because what happened is that the previous product, Jeremy, they let us to do open source, but first over a year, we built it internally, and they were like, oh, let's open source it. And then we figured out it took us over half a year to remove all the internal dependencies and change code to the point when we actually could open source that. That's why when we started Cadence, we practically started to build it as open source project at GitHub from the beginning. So you will find it's like you can go clone that repo and see the practically first check-ins there. And because of that, but it was open source, it was built in the open source. But first 2 years, nobody outside was interested.
Mhm.
But then I think I talked at a few conferences, I did a couple of videos, I think in meetups, and we started to get external adoption. And by the time it was running at Uber for over 2 years at large scale production, so people started to trust this solution because of that.
Yeah. Wow. Okay. You know, you talked about as you, so first of all, that's awesome. So it sounds like this So temporal then is like iteration, what, like 6 or something of solving these same types of problems? Where you started with Amazon Simple Workflow Service, then grew into Cherami, which then took 6 months to could, customize to, make it more open source. Cadence was open source from the start. And so temporal is like kind of like the next iteration on sort of the thinking around this, the lessons learned, the pragmatic things around this. What?
So when we started the company, Temporal is a fork of Cadence, right? So we just forked the code base. And what happened is that we had to fork for all sort of kind of non-technical reasons initially, like mostly around legalities and stuff when starting the company. But we use it as an opportunity to do backwards compatible changes because we kind of promised backwards compatibility always. We ran Cadence for over 3 years, never breaking compatibility. My understanding is that even current Cadence never broke it. And then temporal, we knew that we are not going to break compatibility, but as we forked, we were able to do it once.
Mhm.
And we did so many changes to the core product that it took us practically a year to get to the point when we released our first 1.0 version of temporal.
And
Because
what were some of those changes that you felt, okay, we've got to now or never kind of go, let's go. What did you prioritize in that moment to make sure that temporal was a better starting point?
So the first thing was that we switched from Thrift and proprietary, not proprietary, it's open source, but kind of custom Uber PubS request reply protocol to gRPC and protobufs. I think that was the most important one. Then we obviously changed database schema quite a few places, and we added a lot of kind of things. Like most basic one, for example, at Uber, every payload was just a byte array. And we changed it to payload protobuf, which includes headers. So you could include metadata about every payload, which is a big deal if you need to do encryption and things like that. And also we did a lot of renaming. For example, task list was task queue was called task list because we took it from simple workflow. And I was tired to explain every time to everyone that task list means a queue. And then things like decider, it was not clear to people what decider is, so we call it workflow worker, things like that. And domain became namespace because again, I had to explain that domain is like namespace. And so a lot of renaming, a lot of internal changes, and most important, and obviously gRPC allows to do security and all sort of other things.
Yeah, awesome. Yeah, well, naming things is one of the, foremost hard problems in computer science. So it's nice to like rip the Band-Aid off all at once and make everything more sensical out of the box. That's actually a really smart use of that time and space. You mentioned security. Security is always a spooky story. Talk to me about some of the architectural decisions that you've made. It sounds like GPRC is one of them, but like, are there other considerations that you've kind of had front of mind when developing temporal to help proactively address security problems?
So I think some of that kind of happened organically. But most important thing from security point of view, as it relates to temporal, is that code runs in the user environment, right? So like in the application code, like workers, clients, they are just part of the application. And it also means that you can encrypt all the data. So practically by the nature of the product, that payloads don't need to be inspected by the service. And this makes security kind of much simpler because you practically can say everything is encrypted, service never sees everything unencrypted. And it's much better story than your database, you need to look into the data, but you promise your clients that you're going to be secure when you do that. So, but this is security by you being good, right? Versus security by architecture and by design when I think one thing we want to add a little bit more metadata to those, but my goal is to have practically situation when we can practically cryptographically prove that we cannot hack you, even if we want to, right? So I think idea is that you imagine we are hostile to you, right? But as a service, but still cannot do much. And it's not because we are good again. And again, we still have all the SOC 2 and Type 2 and all the other compliances, and we are good guys. But again, it's much better story when it's you trust your encryption, not that we are telling you that we are good.
Yeah. When your security is trust me, brah, very different than this is secure by design. And even if we wanted to be all nefarious and get in your stuff, we literally can't because of the nature of how this thing is set up. That's very cool. And I think that is often just talking anecdotally to folks, that is often a misunderstanding I think people have about temporal and especially temporal cloud, like this notion of like, well, my code is private. I don't want to give that to some service. And it's like, but you're not though. Like, and I think that is something that a lot of people maybe don't quite understand innately.
Yeah, we need to do a better job there. Yeah, explaining that if you're using temporal cloud, it's secure. And that's why we pass security reviews of like very interesting institutions like big banks and so on.
Yeah. All right, so now we're in our timeline here. We're firmly into like the temporal part. And when I was asking you, like we did some prep work for this meeting, I was asking, what led to this feature, that feature, the other thing. And what you talked about was more like a philosophy, which is, our features of temporal come directly from customers, like what customer pain points are and that kind of thing. And we listen to our customers and we make the changes that make their lives better. Like that's kind of how we philosophize about this. And I'm just curious to know, like, if you had to pick a favorite or maybe three, I don't know, like, sometimes picking a favorite is hard, but if you had to pick a favorite kind of customer request or user request that led to a cool temporal feature, what would it be and what was the story behind that?
Um, I think it's interesting. It's very rarely that we get like serious feature requests, right? Like there are some, but mostly, most of the kind of complex and interesting features come not from requests, but from just talking to customers about their use cases.
Mm-hmm.
And when I talk, I usually try to understand, and sometimes it's clear that there is something missing, right? So like because the whole idea of temporal that make your life easier, right? And if your life is not very easy and there is kind of tension there and you need to work around certain things, then you're probably missing something, right? So
Yep.
that is kind of, and then sometimes it's just scale. For example, local activity was created because we had to support use case which absolutely wasn't possible at Uber back then without that.
Mm-hmm.
And I think if you kind of distill, I thought the marketing use case, by the way, it looks like marketing campaigns is super common and communications is super common right now. We get so many companies using that for that. But back then, the idea was that you practically get an event, which was a signal to the workflow, and that event could run up to 100 or more activities just to determine what to do next. And these activities would call external services. And then it could decide what the next step is. So if we didn't naive, and then we getting around like 10,000 those signals per second to the cluster. And back then our persistence wasn't as good as our cloud persistence. We couldn't support that using Cassandra. And then if you multiply 100 by 100, like 10,000 by 100, right, you get pretty significant rate. And we kind of just realized that we wouldn't be able to support that unless we did something like local activity when all these hundreds of requests are happening in memory and then practically result in a single database update. And that is kind of how, for example, the local activity was conceived and created. The same way, obviously, we talk to customers, everybody, a lot of people want to do interactive workflows. That's why we started to talk about update. And we want to do it for a long time, but just doing it proper took us a while, but now it is out there, you can use it. And another one is situations about from synchronous sagas. So a lot of our users using synchronous temporal to implement low latency transactions, but with compensations, like instant payments, for example. And we are missing certain features around that. And now with update with start and eager task, we can actually have practically as good performance as we would do coding that manually without temporal, but with all the temporal benefits out of the box.
Right. Oh, that's amazing. That's great. Um, I believe the first SDK for Temporal, this was before my time, so correct me if I'm wrong, was Go. How did you make the decision on which was the second SDK that you would target?
That was easier. Uber only had two supported languages.
Oh, okay.
Java and
Okay,
Go,
then yeah, which were those?
Go and Java,
Go and
and
Java. Okay. Yep.
Python technically was some Python and data teams, but we just didn't have capacity to do the Python. Also because actually, if you look at Java SDK, it was actually forked from the Amazon Flow framework, which I wrote while at Amazon, and so we had kind of some base to start it from, not from scratch.
Okay, nice. Yeah.
Yeah, I still
Okay, then what was
reflect.
the third one that you did build from scratch?
Third one, I think, was the first one which Temporal implemented, but actually, okay, it's interesting. Third one was PHP,
Oh,
but it wasn't written by us. It was contributed by it was a contribution, right? And it's built on top of Go SDK. I think our third one was, I think, TypeScript. But to build TypeScript, we had to build Rust core, which is practically the library which is shared by all new SDKs. And then all the new SDKs like Python and .NET and now Ruby are using that.
yeah, awesome. Speaking of temporal features, by the way, I'm just going to pause here. The audience is here. They seem to be listening, or maybe they're checking their email. I don't know. But just so you know, this is a Q&A session. So I just want to call out verbally, in addition to text, feel free to dump your questions into the Slack channel, into Zoom, in the Q&A tool, either way, because Max is like totally fine, like interrupting our conversation with any questions that you might have about, you know, temporal history, you want to quiz him on his knowledge of Russia, whatever, like, you're here to, to do and ask me anything. So, um, on the topic of temporal features, a big thing that was announced at Replay this year was Nexus. I know a lot of people in the audience got really excited when they heard about that. And I'm just curious, like, what's the big deal? For people who don't know what that is, why should they care?
I think Nexus is just very logical expansion of temporal like ideas of durable execution from a single service, a single application to practically the whole enterprise or maybe even world. Because now we are talking about these asynchronous operations, which are kind of being a first-class citizen, right? So you can call an API, it's request reply, but can take any amount of time, can take 100 milliseconds, can take 100 days, but it's still the same API call, and it works across and namespaces, works across regions, clusters in OSS, or even across different technologies. So we want to make a Nexus generic enough to talk to non-temporal systems. So, and it practically can replace what people use for right now for event-driven systems, because people use events to integrate large-scale systems. This is actually a much better way to program. And again, temporal with its durable execution abstraction was already replacing a lot of those, but usually within a single team, within a single use case, because again, the cross-team communication wasn't well done. You had workarounds like calling things from activities, but they were ugly. And now we can have like first-class citizen support, like for real services, for real service definitions, for all visibility, but you get all the benefits of temporal visibility, durability, and so on.
Nice. And that makes it like there's probably a lot of people who are writing the same code right now, like even within their own organizations, they're duplicating code, but definitely across organizations as well. Like how many times do we have to write the plugin for this login system or like whatever? And so is it my understanding, and I apologize because I'm still kind of new, but like, is it my understanding that the idea of Nexus is you encapsulate that sort of workflow and activity logic into something that then becomes more or less a web service call over gPRC. So you don't have to embed all this logic. You just be like, I'm calling out to this thing and I expect this output in return, or how does it work technically?
So there are a couple of things. One is that actually almost everyone I talk to, especially when joins temporal, say why we don't do libraries of activities. libraries of like workflows or activities. For example, integrating with third-party APIs. Like we want to do Slack integration, right? And until Nexus existed, we just didn't, because it would mean that every application have to run this as a library, and we have multiple languages. So it would be problematic. And now you can practically just create, let's say, Slack Nexus service, and then I imagine in the future we will have Freewin community of contributions there. So imagine you create a Docker container, you download this container and run it in your infrastructure, configure with Slack credentials, and then you can just, everyone in your company can just start calling that from workflows directly, and with all the semantic. And some operations can be long-lived if we can map them. And obviously, long-term, I expect maybe Slack will provide it directly as
That'd be
a
nice.
for everyone. And but that is we need to start supporting cross account calls, cross company calls. We don't have all the features there for that, but this is long-term goal as well. I think that is main reason. Underneath, if you look at the implementation, it's all HTTP and HTTP and webhooks and callbacks, but it's kind of underlying implementation. For you, it is much higher level abstraction. It is all fully integrated with Temporal. You don't need to do anything. It just works out of the box.
That's very cool. We have our first audience question of the session, which is from Amit Kumar. Apologize if I'm not pronouncing that right. And he's asking, can you please share some use cases of Nexus so I can get a better understanding? So you used one just now, which is if you're trying to make Slack do a thing when a workflow executes or whatever, like that whole business of like, say, integrating, external notification systems with temporal smarts. But in your mind, or what you've heard when talking to customers, what are some other kind of top use cases of Nexus that you've seen?
I think it's mostly replacing pub subsystems to integrate services within your enterprise. So imagine you're doing ordering application, you have order service, payment service, it kind of all the standard things, but think about it. If you using just normal request reply, right? Like HTTP interface or gRPC interface, like REST or whatever, services are well defined. You have service definition, you can call it, you have a client, and usually if you like press a button, you make a bunch of calls, and then you can return. The problem is that the moment you say, okay, this request can fail and need to be retried, or this request can take 50 minutes, you cannot use you stop using request reply. You're practically forced, okay, now I have to use a pub subsystem, I have to use event-driven system, and your code completely changes. And there are no service definitions because pub subsystems don't have them and so on. With Nexus, you probably can define services the same way you define your REST services or gRPC services, but any operation is guaranteed to execute because it's implemented by through Temporal, and also it cannot take any amount of time. So you can absolutely have charge function which takes 3 hours or maybe 2 days if there is a manual approval as part of that implementation. So it's mostly kind of integrating services. But there are all sort of things in Temporal itself. For example, callbacks. Imagine situation that I think, for example, you're doing deployment system for your company, and there are different technologies to deploy, right? You want to deploy, I don't know, Kafka cluster. You want to deploy a database. You want to deploy Flink cluster. You as a deployment team can say, okay, if you want to integrate new technology, implement this Nexus interface. For example, deploy, cancel deployment, I don't know, get status of the deployment. And then the team will implement that and register it, and then your deployment system will just use it in more like callback interface. So that is also a very common pattern that we see. So just service orchestration and or coordination, and then all sort of callbacks. It replaces webhooks, replaces events.
Very cool. I see some typing in the channel. While that's happening, can you explain search attributes to me? I don't get it, and I don't know why they exist, and I don't know what they're used for. So let's kick off that question. And then Ian, I'll wait to hear from you.
So I think there is this kind of it is actually an interesting general problem like the durable execution and workflows practically they are kind of entities. So and they have primary key, which is a workflow ID, and it's all good, but you want to be able to list them. You want to be able to search them based on some criteria. You should be able to do batch operations on them, kind of, okay, cancel all of them which match this condition. And and obviously our UI and CLI require like these operations like listing things. And that's why we created an index. And initially this index was in Cassandra, but Cassandra has pretty bad implementation secondary indices, so we had to support Elasticsearch to scale. Then we later added support for SQL databases for that. So there is one big tension there is that we practically want to have index, which and then we added custom search attributes, which are practically saying, okay, you can add your own attribute, for example, your own customer ID, your own kind of whatever business ID, and then you can use it in those queries. The problem is that it's still not replacement for a database, right? So if you want to do complex queries, you want to do joins, you want to do very high frequency updates, and especially reads, this search like our what we call visibility APIs, they are not just built for that because they cannot have high read rates. Why? Because the only way you can do that if you do custom schema with custom indexes and custom kind of application specific design. Having this kind of general purpose schema which works for every use case is practically impossible. So which means that you want to use that, you want to use it for your use case. But for example, if it's customer facing, you want your customers list things, you want a more complex reporting, I think you probably should use your use a database with Temporal, not just rely on our index.
Thanks. That was actually very comprehensive. All right, we have a couple of questions pouring in here. Ian says, interesting. I suppose I should read this out in a British accent, but I'm not going to do that because that's insulting. But anyway, interesting on the provisioning story for Nexus. Would you imagine temporal cloud provisioning? There's a fab video from Sergey. I'll go look that up and paste it here. Moving toward implying, would you imagine temporal cloud provisioning, that whole concept, moving towards employing Nexus?
Not imagining that we are talking about that. We absolutely want a dog food Nexus at Temporal. And also, I think I'm not sure if Nexus presentation from the last replay is out, but I think Netflix guys kind of described what they're planning to use that as well for internal provisioning flows. So yes, absolutely. That is absolutely will happen. So because Nexus is the right technology. And again, you can have Nexus endpoint per region. You can have Nexus endpoint per cluster. And I want to push it more. For example, I'm trying to get the Nexus endpoint in every worker. Imagine that you can target every worker and you practically can implement almost any operation there. Everyone wants to be able to read, like, for example, list of workflow types registered with this worker. Or for them, canceling activities without heartbeat. If every worker has a Nexus endpoint, these things become much easier to implement. So Nexus will enable all sorts of technologies. Other thing is ability to do components and extensions to Temporal itself. Imagine you want to add a new feature like scheduling. Ideally, you should be able to implement a Nexus endpoint and register this Nexus endpoint as a component with Temporal, and then you get a new feature. So more things will come around that, around how Nexus will become not just RPC protocol, but how it will kind of used all over Temporal itself. And internally, we are refactoring Temporal internally, and even internal implementation will rely on Nexus protocol very heavily.
Thank you. That's exciting stuff. Amit also asked a follow-up question about Nexus. Nexus appears to be the hot topic. I'm glad I asked about it because now everybody's awake and things. I use Temporal Client to send signal to workflow when they are waiting for user input. Should it be replaced with Nexus?
That is interesting. Yes, they should, but not yet. Because Nexus right now in the first release of the Nexus is only workflows to workflows. So practically, if workflow calls Nexus workflows can call Nexus operations, and then you can implement Nexus operation as synchronous call. For example, you can have Nexus operation which sends a signal to your workflow, or you can have Nexus operation which is a workflow. But one thing which we don't have yet is ability for not temporal clients talk to Nexus directly. We are going to introduce notion of a gateway. So, for example, we can have HTTP gateway, which practically say, this is my Nexus operation service. Let's say it has operation charge. And you would be able to say, okay, expose this Nexus service as an HTTP endpoint. And this HTTP endpoint, for example, supports webhooks to deliver results. And then you would be able to practically call this HTTP endpoint, do charge, for example, call charge operation, provide webhook, and when charge operation completes, webhook will be called, for example. But for example, something like which sends signal, then it will be synchronous operation, so it will be just normal kind of HTTP call to, and which will be, for example, notified price change, right? And that would be transformed to Nexus operation, which can be, again, become a signal to your workflow. But we don't have gateways yet, right? So that is something which is coming. And we will have multiple gateways, HTTP gateways, gRPC gateways, and whatever technology you want, like Kafka request reply gateways. And will be inbound. In this case, you call into the Nexus operation, or you could also expose existing things as Nexus operations. For example, you have a HTTP endpoint. Why we cannot make it callable as with all the retries and everything as a Nexus service from your workflows? So yeah, so the whole idea of Nexus that it's not only about workflows talking to other workflows, it's about external world talking to temporal and temporal talking to external world. So
Are there any performance concerns with all of that, systems talking to other systems and that kind of thing?
obviously, yes. And we put a lot of thought and effort to make sure that there is not much overhead. So underneath it's just HTTP, and we want to make sure that there is not much overhead for these things happening.
Nice.
So
Okay.
at least we're trying to design it as performant as possible.
Okay.
We ruled out quite a few design options which weren't performant.
Because that would be a spooky story on its own. No, I'm just kidding. All right.
Yeah.
So we're at about a little less than 10 minutes left. To the audience, if you are listening and you have a question for Max, you've got him right here as we live and breathe. Feel free to ask it in the chat or in the Q&A tool in Zoom. In the meantime, I want to touch on something. So speaking of replay, during the closing session, Claire, our Temporal CMO, kind of touched on that story that right now, when Temporal goes into an organization, it's often like the lone developer standing against the wilderness, right? And they've kind of seen the light. They know there's a better way to be writing software that is more, it's durable by design. It is, it allows them to just, extract a whole bunch of complicated concepts that they don't even have to think about anymore. They can focus on their business logic because Temporal just takes care of it. So they understand that. And then they go into their organization and often face kind of an uphill battle because, it's like, oh, things are working good enough, or like, we don't want to destabilize anything, or this kind of thing. And I imagine within Uber, where you were first proliferating Cadence, it was similar, right? Like we already have stuff, it's working good enough. Yeah, we get paged every 5 seconds, but we've gotten used to it. We set a drum beat to it now, and we've come to peace with it. How do you recommend, if that lone developer is out there looking at the spooky wilderness, how do you recommend, and what success have you seen from other people? How do they get buy-in on Temporal? What's the conversation that they should be having?
Okay, it's a very complex topic, but there are, I think it depends on organization and whatever. So for example, at Uber, it was very clear that some teams were, for example, overstaffed, and some teams were actually had more work. right? And they're like much more result oriented, right? And if team is overstaffed, they will always say we'll build our own, right? They will never use any external technology, even if this technology is better. And we had quite a few examples of those at Uber. At the same time, team which is kind of result oriented needs to deliver solutions right away. Those teams had no problem adopting the technology. The same thing for other organizations. Usually what I find that obviously startups, that's why we get so much success with startups, because we are the best value proposition for them. You move faster, your productivity is like much, you don't rebuild, like you just focus on your business logic. And at the same time, if you grow and become successful, you don't need to rewrite anything, right? Because Temporal will scale to practically any rates, and we have largest companies in the world using it. So that is, but usually I always ask, where's the pain, right? Where is your pain? And one thing I found that almost every company which implemented, for example, event-driven architecture at scale, I don't need to do much selling there. I just go and say, okay, do you know it's bad? And they're like, yeah, it's bad, but we know there is a better option. And then like, okay, try it out, right? And we always recommend starting small and have a proof of concept and make your own opinion on that, right? And the best cases which we saw a few times when people had legacy system and team around legacy system, and they've got a task and they're like, okay, it will take us half a year or 9 months to implement this. And then like a group of 2, 3 developers would POC that on Temporal in a couple of weeks. And we've seen this multiple times. And that's why I've seen numbers 5 to 10 times productivity gains in certain scenarios. And I think that is very powerful, is that POC something which is hard, POC something which is people are stuck, cannot deliver, or just like that is usually how it works. And then there is a huge legacy system you need to refactor, and you don't know how to refactor that. Temporal is also a pretty good way to prove that just you can improve that. But yeah, sometimes it is uphill battle. I've seen multiple cases when people left companies because company refused to use Temporal in the project. The
Tell them came to work here.
one interesting one was that I think practically what happened is that developer learned about us, POC'd, all the team liked it, but VC practically said, no, you have to use this low code technology, which I kind of, and the developer just left. And then like this company came to us 3 months later and said, sorry, we want to use Temporal because all developers just don't want to use that thing. So that happened.
Because we just hemorrhaged all of our best people because they, yeah.
Right.
Wow, nice.
Yeah.
Nice. That first POC, what is it typically? Like, I imagine they're not gonna, the upper brass is not gonna be like, yeah, why don't you just throw this unknown technology at our extremely user-facing mission critical code the first time out? What kinds of thing, it does eventually get there, right? Like it's used all over the place for that. But, what typically are, when you direct people to do a POC, are there certain like use cases or whatever that resonate with people as that kind of, let's dip our baby toes in the water with this?
You know what? It's kind of interesting. I also had the same idea initially, what you just said.
Mm-hmm.
Reality is that I see a lot of people just going for the mission critical applications almost immediately.
Wow, great.
And sometimes as a first use case. It's not like I recommend like betting your company future on us like right away, but this happens all the time.
Hmm.
And my feeling is not because we are very good selling that, it's just mostly because pain is so large. Because they tried all the alternatives, they understand how painful it will be. They did POC and they're like with this approach, and they're like, okay, it makes sense. And also at this point, obviously, when we are starting, it was much harder. But right now, we've got enough social proof out there, and so many users and client, like awesome clients, that people trust us. Because if we can run workloads for these very large companies, that the people believe that we can run it for them. And so I think at this point, again, where is the pain, right? And in sometimes it is, but yes, if you have very clear use case which is not mission critical, I certainly would recommend starting there just because it's faster. But it doesn't mean you cannot do mission critical stuff as well. And work with us, we can help you to make sure that all the everything is covered, right? Like if you're ready for real production. We
Yeah,
have
and I guess in some ways,
if you're a client of our cloud, right? We provide an awesome support and make sure that you're not just our support is not just support, right? It is actually proactively helping you to implement use Temporal correctly during development cycle, which I
that's
think
right.
is a big deal. Like architecture, development, even code reviews, so we can do all of that.
Yeah, we had Josh on one of these the other week talking about temporal anti-patterns, and that was one of his is like, don't go it alone. So many people are like, cool, I'm gonna sit down with the docs and I'm gonna sit here by myself and read them all. It's like, don't do that. Talk to us, come to the community. The folks in the community are super helpful. Lots of people have tried to solve the exact same problem you have, and we'll be able to speak to it, kind of what worked, what didn't, that kind of thing. So yeah, well said, Max. And it's interesting because I had that preconceived notion, but you're right. In some ways, it's almost better to trial out temporal on a mission critical, or at least a piece of mission critical functionality. It sounds like whatever's hemorrhaging the most pain, because it's like, well, it's already painful. Let's see if we can make it worse. No, I'm just kidding. Yeah.
Actually, one real use case was the one very well-known company. They have dozens and dozens of use cases, and we are self-hosting most of them. And then we're like, okay, let's move them to the cloud. And no. Like, here's the most kind of, I wouldn't say important, but like a very important use case, but highest throughput. Like they're practically, okay, if you can support this one, we will give you the rest. Right.
Mm,
Because, and it's very common because I worked for large companies and it's very common that technology works until it stops working. Right. There is certain scale when it stops working. And Amazon was a good example. It broke almost every third-party technology we tried to use, right? And sometimes in very spectacular ways. And that's why I understand where they're coming from. So they're like, okay, here's the most highest throughput use case we can imagine. Prove that you can do it, and then we will talk about the rest. So that happened as well quite a few times. Mm.
that's awesome. All right, I think we're at time. I have one last question for you, which is, and I've also asked this to the audience. I would love to know, like all the customers that you've talked to, all the folks that you've worked with to become successful as Temporal, what is the weirdest or spookiest, if you want, just like out there, like use case that you've ever seen done with Temporal? Because Temporal is well known. It does payment processing stuff. It does infrastructure management. Like it can do a bunch of kind of well-known use cases. What's kind of like the most creative or out of the box kind of use case that you've seen?
I would say not creative, but I certainly was surprised to learn that people are implementing the practically workflows, like all the paperwork related to crematorium.
Really?
Yes, and
Wow.
it's
Okay.
like I didn't know that they actually said that there is a lot of paperwork there, right? So and they practically implemented the whole paperwork around that using Temporal, and they said their team had very dark humor after that.
Way to just understand the assignment and you wrapped it into a spooky story about a crematorium. Like high fives. That was amazing. Okay, great. Cool. I'm gonna share my screen for 1 second. We're over time. Sorry for that, everyone. But I just wanted to say we have one more of these webinar community AMA session, whatever you want to call them, coming up on Thursday, big day, October 31st. And that's going to be with Tio, who's from our developer success team. And Tio is great because this talk was like standing room only at Replay. And several people who were at his talk were like, I really wish I could watch that again, but pause it and take a bunch of notes. Like everybody's taking a picture of every slide because what his talk was about is basically you have a problem. What do you do next? And it talks about all the different things that have to do with temporal, have nothing to do with temporal, the way to debug any problem that comes your way. So if you're into debugging problems, that's spooky. Please come join us on Thursday and we will welcome to another session. But in the meantime, thank you everyone for showing up. Thank you, Max, for your time. Really appreciate everybody who jumped in, asked Q&A, and yeah, thanks a lot. Join us for the next one.
Thank you. Bye.
All right. Bye, everyone.